Okay, great. Well, first of all, I want to thank Ashley and the staff at the Dauphin County Library System for setting up tonight's Zoom meeting. I'm a regular visitor to the Alexander Family Library in Hummelstown, which is, just a couple miles from my house. And I'm a really big fan of the entire library system. And I know it's a really pleasant Tuesday evening, so at least where I live. So I want to thank all of you for Zooming in tonight. So let's see if I can get this to work. Yeah, so my talk tonight is based on a cover story I wrote for the September 2020 issue of Astronomy magazine. Ashley mentioned I was editor-in-chief of Sky and Telescope, and its big competitor is Astronomy magazine. I also worked at Astronomy magazine from 1995 to 2000 as a senior editor, and I continue to write for both magazines. So my topic for tonight is how scientists are attempting to answer fascinating questions about the prevalence and nature of extraterrestrial life. Now, scientists have discussed and debated these questions for centuries. And obviously the public is really interested in this topic too. I mean, think about some of the blockbuster scientific movies like, E.T., Star Wars, what was that one with Avatar? Movies and books about alien life are hugely popular. But we've had this intense interest in speculation, but this science of astrobiology, the study of life on other worlds, is a science whose subject matter has not yet been proven to exist. We only have a single example of life to study, and that's life on Earth. And every species on Earth shares a similar biochemistry and a common ancestry. So, on Earth, for example, all life is based on the element carbon and is dependent on liquid water. And we don't know, for example, if these are universal characteristics of life or whether radically different life forms might exist on other worlds in our galaxy. Now, we do have good reason to be optimistic that life is common. One of the reasons is that we know from rocks, this is one from Greenland, the earliest rocks we have on Earth, that go back the farthest in time, preserved rocks, show chemical indications that there was life on Earth. So we know that life got started very early in Earth's history when it was still a toddler. So that gives us some reason for optimism, that wherever the conditions are favorable, where there's organic compounds made of carbon, liquid water, and a source of energy, that life will get started pretty quickly whenever you have the right conditions. There's another reason to be optimistic that there's a lot of life out there, and that is that our Milky Way galaxy has around 200 billion stars. And we know from the planets we've discovered to date around other stars, which are known as exoplanets, that there's an average of at least one planet per star. So we can say very confidently there are many hundreds of billions of planets in just our own galaxy. That's not even counting the entire universe. And then when you add in that there could be moons that also support life, the number of worlds in our galaxy that could support life is just literally astronomical. It could be an enormous number. So another reason for optimism is that we have interstellar clouds. That's where stars and planets form. One of the most famous is called the Orion Nebula. I'm sure many of you have seen that either naked eye, telescope, or in binoculars. So this is a giant cloud of gas where stars and planets are currently forming. Well, these clouds are all over the galaxy, and they're brimming with elements like carbon, hydrogen, oxygen, and nitrogen that are essential to life on Earth. So our galaxy is richly endowed with all the ingredients for life as we know it here on Earth. But despite all these reasons to be optimistic about extraterrestrial life, we still don't know how or where life got started on Earth, meaning we cannot completely rule out the possibility that the origin of life on Earth was an incredibly lucky event that has never happened anywhere else in the universe. I mean, I don't think that's true, but we right now can't exclude that as being possibly true. Another important, let's see, there we go. Another important thing to know is that life on Earth started as primitive single-celled microbes, and it remained that way for most of Earth's history. But life hung tough, and over billions of years, it eventually evolved into multicellular life and then very complex plant and animal life. And I'm just, this slide just gives you a tiny sliver of the diverse forms of life that take up many different habitats, everywhere from underground rocks to dry valleys in Antarctica to hot springs in Yellowstone National Park. So we see this dizzying variety of life on Earth. And when there's actually a new book out about how to define life. And what's interesting, when scientists try to define life, someone can always come up with a life form on Earth that doesn't fit in with the definition of life. So we don't even have a really good definition of life. And, we don't know whether the evolution to complex plant and animal life on Earth was inevitable, or whether this was a highly unusual event for a life-bearing world. I mean, there are scientists who think that there could be billions of planets out there, but that have life, but only very simple microbial life. So we don't know, what other forms of complex life are out there. They could be utterly bizarre to us. We'd be bizarre to them. They'd be bizarre to us. And here's I think, creative, imaginative piece of art trying to depict, really weird life on another world. So the bottom line is that despite all the scientific advances we have made in, astronomy, chemistry, biology over the past few centuries, we remain profoundly ignorant about who or what is out there in the vast depths of space. And we're not going to answer these questions by theorizing and speculation. We have to observe and explore, and that's what I'll be discussing tonight. So my astronomy article frames this issue as scientists taking three different roads or approaches to searching for extraterrestrial life. So on the left, we have looking in the solar system with robotic spacecraft. Number two is using telescopes to probe the atmospheres of planets orbiting other stars in search of biosignatures. That would be, chemical indications of life on another world. And then maybe the most interesting of all of these approaches is the search for technosignatures, which are signs of advanced civilizations who are modifying their planets or space environments in ways that our telescopes could detect. So these three roads do not, however, represent a race or competition. We don't know how common life is or how difficult it will be to find it. So it's impossible to predict how soon we'll make the first detection of life on another world or how that discovery will be made. So for me, at least, and probably for many of you, it's comforting to know that scientists are not putting all their eggs in one basket. Now, our technology keeps improving, so I'm optimistic that if life is fairly common in our galaxy, we will make the first detection of extraterrestrial life in the next 10 to 20 years, hopefully in my lifetime. So I want to start off by talking about the first road, which is life in the solar system. And some of you might be thinking, didn't astronomers recently discover life on Venus, which is the second planet from the sun? And probably many of you remember that last September, there was an international team, mostly British and American astronomers, that announced that it had used radio telescopes to detect a molecule known as phosphine in Venus's thick atmosphere. Now, as this illustration shows on the left, phosphine is a molecule consisting of one atom of phosphorus and 3 atoms of hydrogen. So the team thinks it detected phosphine, but it did not claim that it actually detected life on Earth or on Venus. So Earth does have trace levels of phosphine gas in the atmosphere that come from microbes, that's biology, and human industrial activity. So on Earth, phosphine is associated with biological processes. And the team that made this discovery tried to think of every conceivable way that you could make phosphine in Venus's atmosphere without life. And they couldn't come up with any known process that would produce phosphine. So it proposed that this phosphine might be produced by microbes in Venus's atmosphere. Now, the surface of Venus, as probably many of you know, is inhospitable to life, at least life as we know it. The temperatures reach about 900 degrees Fahrenheit. That's like hotter than my oven that I used to cook lunch today. The atmospheric pressures are absolutely crushing, like being deep underwater. So the team detected this phosphine in an atmospheric layer that's about 30 to 40 miles above the surface, and that it has very mild temperatures and pressures. And scientists, including Carl Sagan, have speculated for decades that molecules could be circulating in the cloud layers at that level through updrafts and downdrafts, kind of like this wheel we see in this illustration. But the clouds at that level on Venus consist of sulfuric acid, which is really nasty stuff. And there's virtually no water there. So if there's life in this layer, it is life that's way different from anything we have on Earth. And I should also mention that other scientists have tried to detect phosphine and have come up empty. So it's questionable whether the team even detected phosphine. My guess is they did, but only in very, very small amounts. So, to me, it's not at all clear. It's by far from proven that there are microbes circulating in Venus's clouds. And I think it's actually pretty unlikely, but we're not going to really know for certain until we send a mission to fly in Venus's atmosphere that can sample its atmosphere. So I found this on Google Images. This is an artist rendering of a future robotic airplane flying in Venus's atmosphere. Such a mission is a long way off. To my knowledge, there are no planned missions right now for a Venus airplane, but this is what it might take to resolve this mystery. So I now want to turn our attention to Mars, which is the next planet out from the sun, after Earth. And Mars periodically comes close to Earth, as it did a few months ago, making it relatively easy to observe with telescopes, but also to reach with robotic spacecraft. Now, for centuries, many people assumed that Mars was inhabited by abundant vegetation and even intelligent life, like, for example, H.G. Wells' War of the Worlds, or Edgar Rice Burroughs, or was it Ray Bradbury who wrote The Martian Chronicles? We have all sorts of science fiction based on intelligent life on Mars. But NASA spacecraft visits to Mars in the 1960s and 70s disabused humanity of those notions. These early spacecraft showed that Mars's surface is very cold, dry, and barren, and lacking any obvious signs of life. Well, that was the bad news, but there's also, these spacecraft had some good news. And that is that these are 2 photos from Viking orbiters that showed that there are these channels, and these are all over Mars, especially in the equatorial regions, that look like the same types of channels we see on Earth, that are carved by liquid water, you know, rivers and streams. I mean, these almost look like if you dried out the Mississippi Delta or the Nile River Delta, this is what you would see. So this led to the idea that Mars at one point in its distant past had liquid water flowing on its surface. And there's been several NASA Mars rovers over the last 15, 20 years that have really proven the idea that liquid water once flowed across Mars. And on Earth, everywhere we find liquid water, we also find life. So this leads to the idea that maybe Mars once had life, and as it lost its atmosphere into space, maybe the life retreated underground, and there might still be life on Mars today. So in 1976, NASA landed 2 robotic spacecraft known as Viking 1 and Viking 2, and these were the first successful robotic landings on Mars. So on the left, we see a model of one of these landers, and on the right, we see an image from the Viking 1 lander. That big rock, in case you're wondering, was nicknamed Big Joe. What a great name for the rock. So each of these 2 landers carried mechanical arms that could scoop up soil samples, bring them inside the lander, and then each lander carried 3 experiments to analyze this Martian material to see if it contains microbes that contain, or that can, basically contain microbes that consume organic nutrients and then release gas as a waste product. Now, one of these experiments actually returned positive results for life, and this remains controversial to the present day. But there was another instrument on the Viking landers that looked for organic compounds in the soil, and that came up empty. So most scientists think that the upper layers of the Martian soil are completely devoid of life. But once again, it's not a universally held opinion. So unfortunately, though, and I'm actually a little bit critical of NASA, is that we've never sent a dedicated life detection experiment to Mars to follow up with these really tantalizing Viking biology results. Now, there are other hints that maybe, just maybe, life is eking out an existence on Mars right now. And this is probably the most technical slide I have in the presentation. And this is data from NASA's Curiosity rover, which has an instrument that can measure compounds in the atmosphere. And it detected tiny amounts of methane in Mars's thin atmosphere. And, on Earth, 95% of the methane in Earth's atmosphere has a biological origin. So what about Mars? We can see here that the methane levels kind of rise in the spring and summer, reach a peak in the late summer, and then decline in the autumn and into the winter, where they kind of bottom out. This is kind of what you would expect if Mars has life, that maybe during the summer, there's methane, Martian microbes that are exhaling methane. So the origin of this methane remains a mystery. Maybe we're seeing a biosignature, maybe we're not. So it's kind of like the phosphine on Venus. We're seeing kind of intriguing potential biosignature, but we can't use it to prove the existence of life on another world. Now, on February 18th, just a few months ago, NASA landed its latest rover on Mars, which is named Perseverance, but we'll call it Percy for short. That's what the scientists call it. So this was an amazing technological achievement for our space agency and its team of brilliant scientists and engineers. And, from my opinion, it generated a dose of really much needed good news during our troubled times. And then the news has gotten even better over the past week or two, now that NASA has done several test flights of the Ingenuity helicopter. So Percy landed in an ancient crater called Jezero that is an ancient river delta. This is a false color image. And you can see there right in the center, that looks like a dried up river delta, and that's what it is. So they're hoping that, this rover is going to find rocks that formed in liquid water. Now, NASA is touting Percy as a life-finding mission, but that's actually misleading. I don't think that's an accurate assessment of the mission. The truth is, and don't tell anyone I said this, well, actually you can, Percy is not carrying a single instrument that's really capable of detecting past or present microbial life on Mars. Now, Percy could detect mineralogical signatures of life, minerals that formed in the presence of life, or it could take images of like fossilized life. But, nothing like that has been seen from earlier NASA landers and rovers. So I think it's very unlikely that Percy is going to find evidence for life on Mars. But its biggest contribution stems from the fact that it's going to collect rock and soil samples. And then NASA and the European Space Agency are planning a joint mission to launch about a decade from now to return Percy's samples to Earth. So in my view, the rover's mission won't be complete until its samples are brought back to Earth. The current plan is that NASA will provide a fetch vehicle to pick up the samples, and then a rocket that we see here to launch those samples off the surface of Mars. And then it will rendezvous with a vehicle built by the Europeans that will rendezvous, collect the samples, and then send them back to Earth. Now, as you can guess, and I'm sure many of you are thinking this right now, this is a technologically challenging mission. But if it works, scientists will be able to study Martian materials in our best laboratories on Earth. And if scientists in those materials find either fossilized or living microbes, that will resolve the life question on Mars once and for all. And Percy will soon have additional company on Mars. And to be honest, I'm more excited about this mission. So in late 2022, a little more than a year from now, the Europeans are going to launch their own rover named Rosalind Franklin. And it's named, she was a great British scientist who helped discover the double helix structure of DNA. And unfortunately, she didn't get the credit she deserved in her lifetime, but that's a story for another talk. So on June 10th, 2023, Rosalind Franklin will land in this ancient Martian lake bed known as Oxia Planum. And the Europeans chose this site because of its high potential for preserving ancient rocks formed in liquid water. So this rover is going to carry a suite of cameras, scientific instruments, and perhaps most importantly, a drill. The cameras are going to look for signs of, past or current biological activity in the textures of rocks, but the drill is going to dredge up material from up to 6.5 feet below the surface. This is going to be the deepest drill we've ever sent to Mars. Bring that material up into the rover, and then there's a laboratory that's going to crush that material into a powder, then heat it, and then analyze any released gas for signs of organic compounds and biosignatures of past or current life. So if Mars has life at or near its surface, I think the Europeans could beat NASA to the punch. We'll just have to wait and see. But if robotic missions cannot resolve the life question, perhaps future human explorers can dig down into underground lakes, aquifers, and hydrothermal areas that could, possibly have life. These are the most likely places where we'll find microbial life. So I like this particular art in particular because we have some children, and who's to say that someday our colonists to Mars won't include children? So finding life on Mars would be an incredible discovery. If the life on Mars has some kind of evolutionary linkage to Earth life, it would imply that life originated on one planet and was transported to the other inside a meteorite, because planets do exchange rocks. Or it could imply that life on both planets was seeded from a common outside source. But imagine for a moment if we find Martian life and it is completely unrelated to Earth life, like has a different biochemistry or doesn't use DNA for its genetic code. That would imply that life originated independently on both planets. And I said earlier, we have hundreds of billions of planets in the galaxy. If you have two planets, where we look and find life in our solar system that each originated life, that would mean that life is easy to start. And that would tell us right then and there are billions of worlds just in our galaxy that have life. That would be an incredible discovery. So I want to just quickly mention too that there are several icy moons in the outer solar system that are potential abodes for life. Some of the prime candidates include Europa, we see on the left, that orbits Jupiter, but also Saturn's moons, Enceladus and Titan. So there is considerable evidence that these moons contain large volumes of liquid water beneath their icy surfaces. Now, NASA is developing an orbiter of Jupiter that's going to make dozens of flybys of Europa, and they're also planning a helicopter mission to fly in Titan's thick atmosphere. So in the coming 10 to 20 years, I don't think we're going to find life on these worlds or these moons, but we're going to learn a lot more about their potential for hosting life. Okay, now I want to leave our solar system behind and turn to planets orbiting other stars. And I checked the website exoplanet.eu just about an hour or 2 hours ago. The current count of number of known exoplanets, those are planets orbiting stars other than the sun, is 4,720. So that is 590 times as many planets as we know orbiting the sun. But these planets are just the ones we know about are just the tip of this enormous iceberg. As I mentioned, our galaxy has hundreds of billions of planets, but even the closest one of these worlds is about 4.25 light years away. That's 25 trillion miles. So that's an enormous distance by human standards. So how can we study them for signs of life? So this is the only animation I have in my presentation. The easiest planets to study with our current technology are those whose orbits line up with Earth in such a way with our line of sight so that every time they go around their star, they pass in front of the star during part of their orbit. And so we can see from this animation that from Earth's perspective, as the planet passes in front of the star, it blocks a small amount of the star's light, causing a slight dip in the amount of light we observe here on Earth. These planets, by the way, are known as transiting planets, and most of those 4,720 exoplanets were discovered using this method. Now, besides discovering planets, as the planet crosses in front of the star, some of the star's light is going to pass through the upper atmosphere of that planet. And as this illustration shows, there's going to be atoms and molecules that in the atmosphere of the planet that are going to absorb or deflect some of the star's light, making that star slightly fainter at specific wavelengths of light. So, this effect shows up in the star spectrum. So what astronomers are doing is they can take a spectrum of the star when the planet is transiting in front of the star, and then at a time when the planet is not in front of the star, and compare the two spectra. and they're going to see additional of these dark lines in the spectrum when the planet is in front of the star. And that's from the light, being blocked by the atmosphere. And this acts like fingerprints. It helps us identify atoms and molecules in the planet's atmosphere. And astronomers have already used this technique to find things like water vapor and carbon dioxide in the atmospheres of certain planets. So, it's generally thought, though, that to really detect the very subtle hints of biosignatures, we're going to need the next generation of telescopes. The current telescopes aren't quite sensitive enough to do it. The good news is we have one of these telescopes is going to be launched later this year, called the James Webb Space Telescope, which is a much larger telescope than Hubble, so it's much more sensitive. It's going to be optimized to study infrared light, not visible light. So it's going to be optimized to detect biosignatures such as water, ozone, and methane in exoplanet atmospheres. And consortiums of astronomers are also constructing 3 enormous land-based telescopes that I have pictured here, all of which are expected to come online between 2025 and 2030. Now, these telescopes are going to dwarf all the telescopes in the world right now, and they're going to be equipped with the best instruments, and they're going to be able to see faint exoplanets and really get better resolution to try to find these biosignatures that I discussed earlier. And because they're on the surface of Earth, they can also do visible light observations and detect things, also like water and oxygen. So if life is common in our galaxy, there's a decent chance that these telescopes, probably all 3, will detect biosignatures in the next 10 to 15 years. But we also have to remember the lessons of the phosphine on Venus and the methane on Mars, and realize that evidence for life on these exoplanets might be ambiguous. So astronomers are also developing telescopes that use advanced instruments to blot out the light of the star. Because think about it, if let's say you're at another star and observing the solar system, the sun is going to shine about a million times brighter than the reflected light from Earth. So astronomers are developing techniques to block out the light of the star so they can study the nearby planets without the planets being lost in the glare of the star. So an international team is working on this telescope called Exo Life Finder, or ELF for short. Now, if this telescope is funded and then built up to its specifications, it'll be able to study hundreds of exoplanets. And this includes planets that do not transit their stars. And that's actually a large majority of the planets in the universe. We will not see them cross in front of their stars. And this telescope could probe all the way down to the surface of a planet and even resolve clouds, oceans, and continents on some of the closest planets, orbiting stars closest to Earth. So a telescope like this, or future space telescopes, could potentially resolve the question of how common life is in our galaxy. And now we've reached the final part of my talk, which is the search for extraterrestrial intelligence, which goes by the acronym SETI. I'm assuming many of you have heard of the term SETI, and this includes the search for technosignatures. Now, since the early 1960s, astronomers have been using radio telescopes and radio arrays to listen for radio signals from other civilizations. And the reason we choose radio is that radio waves are a form of light, so they travel at the speed of light. Uh-oh, my phone's ringing. I'm going to hang up real quick. All right, sorry about that. Sorry about that. I thought I'd muted my cell phone. That was my landline, kind of ancient technology. In any event, astronomers are using radio waves or listen for radio waves because radio waves travel at the speed of light. That's the fastest possible speed. And also, it's relatively easy to produce and receive radio waves. You don't, we had this technology like in the 1940s and 50s. So that means we could detect any civilization at our current technological level that wants to send out radio signals. So here we see one of these radio arrays that does SETI. This is called the Allen Telescope Array. And this was initially funded by Microsoft co-founder Paul Allen, and it was specifically built to do SETI. But I do want to emphasize that SETI is only a minor part of what radio astronomers do. Radio astronomers spend most of their time studying, natural objects like stars and galaxies and black holes. Now, before delving further into SETI, I do want to talk very briefly about Oumuamua. This is an object from interstellar space from some other star system that raced through our solar system in 2017. Now, there's a Harvard astronomer who has a new book out that claims that this is not a natural object, that it was constructed by aliens. Now, this claim has gotten a lot of attention in the media, and I suspect that this astronomer is selling a lot of books because of his sensationalistic claim. But I want to assure you that this idea is rejected by the vast majority of scientists, and for good reasons. For decades, astronomers have anticipated that interstellar objects, just like Oumuamua, would occasionally pass through our solar system, but it's only been in recent years that our technology has gotten good enough to detect them. So there's every reason to think that Oumuamua is simply a comet or an asteroid that was ejected from its parent planetary system, and it just happened to, wander through our solar system. I don't want to go into more detail about it now, but I'd happy to discuss this during Q&A if any of you are interested. And I also just want to mention that I'd be happy to discuss the subject of UFOs during the Q&A as well. And I realize that is a very contentious subject. So I want to get back to SETI. The most advanced current SETI project is known as Breakthrough Listen, and it's funded by this tech billionaire at the upper left named Yuri Milner, who gave the project $100 million. The project is currently using these two radio telescopes, one in West Virginia for the Northern Hemisphere, one in Australia for the Southern Hemisphere. By the way, I took both of these photos because I visited both of these observatories. And this is a fairly sophisticated project. They're surveying, thousands and thousands of different stars, trying to detect radio signals. That we don't have any conclusive radio detections of ET yet. There have been some interesting, candidate signals. I gave a talk last week to the Astronomical Society of Harrisburg about one particularly interesting candidate signal. But at the moment, we don't have any surefire radio detections of another civilization. But this project is still at a pretty low level. It's like comparing the searches to date would be like the volume of water in a bathtub, when we really need to search the volume of water in all the oceans on Earth. So we've just barely scratched the surface. But the searches are getting better and better. For example, they now use receivers and computers that can listen to millions of radio channels simultaneously. So if there are radio transmitting civilizations out there, one of these days we might find it. There's also several other groups, including Breakthrough SETI, that are searching for powerful laser signals transmitted by other civilizations. This is a field known as Optical Seti. The most advanced of these projects right now is led by Shelley Wright. She's an astronomer at the University of California at San Diego. And you can see on the right, they're building 4 observatories, 2 in the Northern Hemisphere, 2 in the Southern Hemisphere, each with 88 wide field telescopes that are going to look for pulses of light less than a billionth of a second in duration, which would be a very clear sign of an artificial origin. But we also could detect a civilization that is not actively trying to signal us. For example, a few minutes ago, I showed you a picture of the proposed Exo Life Finder telescope. If that thing ever gets built, it could discover technosignatures. For example, one of them would be, it could find the chemical signature of chlorofluorocarbons or other pollutants in the atmospheres of nearby exoplanets. And even more exciting, it could potentially detect the signature, the heat signatures of cities on planets orbiting some of the closest stars. So this is a wonderful artist rendition of an alien city, and I have no idea what those alien cities would look like. And also, here's another idea. In 1960, the great British American physicist Freeman Dyson popularized this idea that a highly advanced civilization could build a spherical swarm of space colonies around its host star to harvest most of the star's radiant energy. So this is an artist's depiction of one of these, what one of these Dyson spheres might look like. These Dyson spheres would collect the light of the star, but they have to re-radiate the waste heat, and that would be in the infrared as infrared light. So astronomers have actually used infrared telescopes to look for Dyson spheres. They haven't found any yet, but they're going to continue to look. And this is just one possible, technosignature that, that astronomers could look for and maybe find intelligent life. So to conclude, regardless of how it comes about, the conclusive discovery of another civilization would be a transformative event for humanity. I mean, if the civilization is far more advanced than us, which is highly probable, it would give us reason for optimism that, a relatively primitive civilization like ours can survive its technological adolescence. It might also answer a question of whether humans have a post-biological future where we either merge with machines or produce artificial intelligence that takes our place. And confirming the existence of another civilization would have profound ramifications in ways we cannot predict, especially if we could get detailed information about one or more civilizations. And even if we just detect something like primitive extraterrestrial life, like plant life, even that would be fascinating. It would give us insight into our own origins and the types of planets and environments that can support life and what kind of alternative life forms might be possible. As I mentioned earlier, life forms that would be totally different from anything we have on Earth. And I would even argue that, let's say we build these space telescopes and, the ground-based telescopes, and we go we explore the solar system thoroughly, and we go decade after decade without finding extraterrestrial life. And it forces us to conclude that life is a fairly rare phenomenon. Even that would be very interesting because it would imply that one or more very rare events happened on Earth. So no matter what we find or don't find, the search for life on other worlds will tell us a lot about ourselves and our place in this wondrous universe. So I want to thank all of you for listening. And here are 4 books on extraterrestrial life that I highly recommend. The 2 books on the left are available through the Dauphin County Library system. The book on the right just came out a few weeks ago. So I look forward to taking your questions. Thank you for paying attention. And I will end the share. There we go. Okay, great. Thank you all very much.
Robert, thank you so much for that wonderful presentation. Again, everyone, if you have any questions, we have about 10 minutes left. You can use the chat, or if you'd like to go ahead and unmute your microphone, you can do it that way as well. Okay, we have a question. Robert, do you have any favorite science fiction books or authors?
Okay, I wouldn't say that I have a favorite book. And that's a great question, by the way. There is one author who I really, really like, but his books are a little bit awkward to read because he was Polish, so they're translated into English. And his name is Stanislaw Lem, L-E-M. He wrote a book that what was the name of the book? Oh, Solaris, S-O-L-A-R-I-S. That's been made into a movie both by the Russians and by George Clooney. And I've seen both versions of the movie. I actually think the Russian version is a better movie. But the book itself, I think, is better than a movie. It's about humans venture out into the galaxy and we find a planet where it's covered with an ocean, and the ocean turns out to be sentient. And so it's totally bizarre life form. So the book is about like our attempt to communicate with the ocean and the ocean's attempt to communicate with our astronauts. And I think it's a very profound book that really is incredibly imaginative in portraying other life that's very, very different from life on Earth. But Lem has written other books as well that I think are just as good as Solaris. I'm also a big fan of Arthur C. Clarke as well. And Ted Chiang has written some wonderful short stories too. So the movie Arrival, which came out a few years ago, I thought that was a great movie.
Great, thank you. And everyone, in a follow-up email with the link to the recording of this, I will include the authors that were mentioned tonight. Let's see, we had a couple more questions come in. What are your thoughts on Dr. Greer and the CE5 documentary?
You know, I'm not familiar with that. Whoever asked the question just follow up, maybe unmute and tell me a little bit more about that, because I'm not familiar with it.
Hello?
Yep.
Yeah, you can hear me?
Yep. Yep.
Okay, so the CE5 documentary, he touches on human-initiated contact. And there's a lot of things of these people getting together in their groups, and he has this whole meditation thing that they do that you have to open your mind to accept everything. And these people have these things, and UFOs show up. And Dr. Greer seems like he's pretty respected among the UFO people and everything. And it was just very interesting to me.
Okay. No, and I really appreciate the question. So I have to be honest, I just don't know enough about this group or Dr. Greer that I don't feel it would be appropriate for me to comment, just because I plead ignorance and I just don't know much about that. What I can say is that, the Navy and the US military has taken videos in recent years of these very strange objects that appear to be, performing aerodynamical feats that are well beyond anything that humans are capable of constructing right now. The Department of Defense has admitted that the videos are authentic and that they don't have an explanation for what's being shown in these videos. I find it really intriguing. I don't quite know what to make of it. It's intriguing. It could be evidence of aliens are visiting Earth, or maybe there's other explanations, that are more earthly. It's really, really difficult to know right now. I would reference, and this article came out just a couple days ago, the new issue of the New Yorker magazine has a very lengthy article about UFOs that I found to be very balanced and well researched. It you know, kind of gives both sides of the argument, I think, in a way that's, you know, fair and honest, on, you know, from people who believe that some UFOs are extraterrestrial visitors, but also giving, you know, the more conventional mainstream scientific perspective that they are, you know, just hoaxes or misidentifications of, you know, human or natural phenomenon. So right now I'm kind of, I don't know what to believe. I mean, it's, you know, I used to kind of not take UFOs seriously, but those Navy videos are, you know, and you hear the pilots talking in the background. The one that I find really interesting is where the pilot says, "I don't know what that is, but I wish I could fly one." Okay, the pilot is seeing something really interesting and it's being caught on video. And I do find that compelling. So I'll just leave it at that.
Okay, we have 3 more questions.
Great.
The first one is, do you recommend participation in an organization if you want to know more?
Yeah, and I, you know, the first organization I would recommend is the Astronomical Society of Harrisburg. I gave a talk to them about a week ago about one of these really interesting radio signals from a nearby star called Proxima Centauri. So it's a great club. They have, you know, a lot of great speakers. You know, the club's active in doing scientific research. They do public observing at their observatory in Lewisberry, Pennsylvania. Of course, a lot of things are kind of on hiatus right now because of the pandemic. But, you know, the pandemic is, at some point it's going to end, and then they'll be able to resume normal activities. So I would absolutely recommend, you know, trying to get involved in the Astronomical Society of Harrisburg. And I should also point out, I mean, I've seen some really great planetarium shows at the William Penn Museum. So those are just 2 local organizations right off the top of my head that I think, you know, could certainly be helpful to anybody wanting to get more active in this area.
Great, thank you. Okay, we have 2 more. Can you explain ETA aquarids that we could see tonight? Sorry.
Oh, okay. So that's a meteor shower. I haven't actually followed. Let's see. I'm looking out my window right now. Looks like it's going to be cloudy tonight. So I haven't really followed this particular shower. The name aquarid means that they appear to, you know, the meteors appear to originate from the constellation Aquarius. And so these would be just 2 you know, tiny little dust particles that are burning up in Earth's atmosphere. The one thing I can say is, to see meteor showers, you want naked eye, you want as wide a field as possible. That means no, you know, telescopes or binoculars. You want to go out as far away from the city as you can go, so you're not being, you know, the sky's not being polluted with lights from cities and towns. So go as far out into the country away from city lights as you can go. And you want to lay on your back, maybe get a towel or a blanket, and look up with your naked eye and just try to see as much of the sky as possible. And that's the best way to observe meteor showers. Sometimes you could even get like a reclining chair where you can lean way, way back if you don't want to lie on the ground. But that's the key thing, is give yourself as wide a field of view as possible. So for example, you don't want to be in a forest, you want to be in an open field where you have a wide field of view, and look up with your naked eye, trying to see as much sky as possible, and go as far away as you can from city lights.
All right, next is, what made you want to pursue science journalism?
Okay, that's actually a really interesting question. When I was an undergraduate in college, I was actually a history major, and I got my undergraduate degree in history, but I took a lot of courses in physics, astronomy, and geology. And a few years later, when I was trying to figure out what I wanted to do next in my life, I saw an ad in Science News magazine, which I subscribed to then, and I still subscribe to it today. It's a great magazine, and they had an ad for a graduate degree program in science journalism at Boston University. And I didn't even know such a field existed at the time. I was in my early 20s. And I said that would be a really cool thing to do for my career. So I applied, was accepted, went through the program, did an internship at Sky Telescope, eventually got a job at Discover magazine in New York City. And that kind of got my foot into the door and led to my career in science journalism. But it's been a great career. I've worked at a bunch of different magazines, and now I like just being a freelancer where I can just write about what topics interest me the most for whatever publications I want to write for.
All right, it is 8 o'clock, so that brings us to the end. However, Robert, I don't know if you have a minute or two. We have one last question that came in. That's a really good one, I think.
Okay, no, I'll be happy to take it. Yeah, happy to do so.
What do you think we should say when we try to contact intelligent life?
That's a really, really interesting question. And this was actually the topic of a big part of my talk last week to the Astronomical Society of Harrisburg. My view, and I'm just going to give you my opinion, because you talk to different people, you're going to get different opinions. You could talk to 100 people and get 100 different opinions. I don't think that we should purposefully, we could right now, if we wanted to, send very powerful radio broadcasts into the galaxy that any civilization at our current level of technology would be able to detect, even if they're on the other side of the galaxy. Although if they're on the other side of the galaxy, it would take our signal tens of thousands of years to get there, even traveling at the speed of light. My view is that we should not do this until this has been thoroughly discussed at an international level, preferably through the United Nations, and that you're never going to get complete agreement. You're never going to get the entire human population to agree on anything at all. So you're never going to get 100% agreement, but I would like to see no signal sent out purposefully to try to, talk to other civilizations until this has been debated and discussed at the United Nations, and you have governments representing a super majority of the human population, like at least 2/3, maybe 75, 80%, that all agree that yes, we want to do this. That would be A, and B, what we're going to include in our message. I wouldn't feel comfortable having like private individuals do this, or private organizations or a nation state do this on its own without first, getting input from the whole rest of the world, where, not 100% agreement, but, widespread agreement, where you have a large percentage of the human population saying, yes, we think we should do this. So, this has been discussed. There's been a lot of discussion about this. It's known as METI, for messaging extraterrestrial intelligence. And you have people who say we should not do this because we might attract the attention of civilizations that might want to do harm to us, all the way to people say this is the obvious thing to do. Let's try to start a conversation with another civilization. It would be fascinating and we could learn a lot from another civilization. So I fall somewhere in between, but my main point is we should not send out a signal intentionally until we have pretty large amount of agreement that we want to do this as a species. And I would also point out, you know, it's not just a signal from humans. There are a lot of other life forms on this planet, you know, that share the planet with us. And, you know, we have a responsibility to all the other life on this planet, you know, to make sure we're not just subjecting Earth to any kind of danger. So that's my opinion, but I understand there could be people who would agree or disagree with what I said.
All right. Well, thank you so much, everyone, for joining us. Thank you, Robert, for this presentation and wonderful Q&A. We have lots of thanks coming in through the chat for you.
Oh, great.
So yes, thank you. And I hope everyone has a great night.
Yeah, thanks everybody. And thanks for the great questions. And thank you, Ashley, and to the Dauphin County Library System. Thanks.